Hello everyone. In our previous sessions of this playlist, we have gone through a number of classifiers in machine learning. Logistic regression, decision tree, support vector machine, all these are different algorithms to solve classification problems in machine learning. Today we will be discussing on Naive Bayes algorithm. Naive Bayes algorithm is also a supervised learning algorithm to solve classification problems. In this session, we will understand how Naive Bayes works internally and how can we implement Naive Bayes algorithm with the help of sklearn library. We will write some code and explore the methods sklearn provides in order to implement Naive Bayes algorithm. This algorithm works on Bayes theorem of probability. I hope all of you are aware about Bayes theorem of probability. Bayes theorem solves the conditional probability problems. Let's understand how Naive Bayes algorithm works internally. We know the Bayes theorem is something like this. Here we will evaluate probability of A when B is given. The equation is something like this. Probability of A given B equal to probability of B given A into probability of A by probability of B, where probability of B is not equal to 0. Let's understand how Naive Bayes algorithm uses this Bayes theorem to predict the dependent variable or the target column. For simplicity, I have taken a small example here, where based on humidity and outlook, we will be predicting if there will be rain for a particular day or not. So rain will be our dependent column or the target column, what we will be predicting based on humidity and outlook of that day. So humidity and outlook are independent variables in our problem statement. If we replace A with the target column and B with the independent columns, we get something like this. Probability of rain given humidity and weather outlook equal to probability of humidity comma weather outlook given rain into probability of rain by probability of humidity comma outlook. We are simply replacing B with the independent columns and A with the dependent columns. Hope you have understood till now. In Naive Bayes algorithm, to make the calculation simple, we assume all the features are independent to each other. And from probability standpoint, we know if A and B are independent, then probability of A comma B will be probability of A into probability of B. So we can replace probability of humidity comma outlook as probability of humidity into probability of outlook. Similarly, probability of humidity comma outlook given rain will be something like probability of humidity given rain into probability of outlook given rain into probability of rain. Now let's generalize this. In our real life machine learning problem statements, we can have a number of independent columns. Let's assume we have n number of independent columns and a single dependent column. What will happen? We will be evaluating probability of y given x1, x2 till xn. All these are nothing but the independent columns of my generalized problem statement equal to probability of y pi I equal to 1 to n probability of xi given y. We are using pi because here we are not summing them up, we are multiplying them up. So pi will be here for n number of independent features, and in the denominator it will be probability of each features, probability of x1, probability of x2 till probability of xn. And as we have assumed in Naive Bayes algorithm that all features are independent, hence all these values will be multiplied with each other following this theorem of probability, where probability of A comma B is nothing but probability of A into probability of B. Now if we assume the denominator is the constant value, we can write probability of y given x1, x2 till xn is proportional to the probability of y pi I equal to 1 to n probability of xi given y. And from here we can evaluate the value of y with this formula. Argmax probability of y pi I equal to 1 to n probability of xi given y. Argmax is most commonly used in machine learning for finding the class with the largest predicted probability, as we are solving the classification problem with the help of Naive Bayes algorithm. Hope you have realized what is the key mathematical equation for Naive Bayes algorithm. Enough of mathematics, let's understand the other key points related to Naive Bayes algorithm. There are three different types of Naive Bayes algorithm: Bernoulli Naive Bayes algorithm, Multinomial Naive Bayes algorithm, and Gaussian Naive Bayes algorithm. Now the question is which algorithm to choose for our machine learning problem statement. Let's understand the thumb rule to use different types of Naive Bayes algorithm to solve classification problem in machine learning. Bernoulli Naive Bayes used when all features are binary, either 0 or 1 or true or false, something like this. Multinomial Naive Bayes used when features have discrete value. We apply Gaussian Naive Bayes when the features are continuous and in normal distribution. If you remember all these thumb rules, you can easily identify which Naive Bayes algorithm to apply for a specific machine learning classification problem. Let's understand how we can implement Naive Bayes algorithm in our machine learning code. From sklearn, we can import a specific Naive Bayes algorithm. In this case, we are importing Gaussian Naive Bayes from sklearn.naive_bayes. Once we import the algorithm, we can create the model with the help of the constructor. In this case, we are using Gaussian Naive Bayes to create a Naive Bayes model. Next step is to use model.fit method and pass training data in order to train the model. It is very similar to any other algorithm we use in sklearn. Model.score will provide us the accuracy of the model. Remember, in case of score method, we will be passing test data as its input. Naive Bayes is a very fast and easy to implement machine learning algorithm, and hence it is very popular algorithm among machine learning engineers and data scientists. However, the disadvantage of Naive Bayes algorithm is it assumes features are independent, but in real life most of the features are dependent, and only for this assumption sometimes Naive Bayes algorithm performs poorly. Let's jump to Jupyter notebook and write some code in order to implement Gaussian Naive Bayes algorithm to solve a particular classification problem. In this notebook, we will be implementing Naive Bayes classifier to classify species of iris flower. We are importing pandas to perform data preparation step. We are importing iris dataset from sklearn sample dataset. We know about train test split method, which is available in sklearn.model selection. With the help of this method, we can split the entire dataset into training data and test data. And finally, we are importing Gaussian Naive Bayes algorithm from sklearn. Once we have imported all the necessary libraries in our notebook, let's start data preparation step. We are loading iris data from sklearn sample dataset. Iris dataset has few important directories. Data directory will have the records of independent columns or features. Feature names has the list of feature names or the independent column names. Target directory has the dependent column value. Target names has different species of iris flower. Let's create feature data frame and target data frame to use them in our machine learning code. If you see, the content of features data frame has sepal length, sepal width, petal length and petal width. Based on these four independent columns or the features, we will be classifying the species of a specific iris flower, and that is what we have in the target data frame. We have three different classes of iris flowers: setosa, versicolor and virginica. In our species column, 0 will be representing for setosa, 1 for versicolor and 2 for Virginica. So based on sepal length, sepal width, petal length and petal width, we will be classifying a specific iris flower among these 3 species. The flower will be either setosa or versicolor or virginica. Hope you have understood the data set. Let's split the entire data set with the help of train test split. We are passing featured and target data frame. Test size equal to 0.2 means 80% of the entire data set will be for training data and 20% of the entire data set will be reserved to test the model. We are adding shuffle equal to true. By this, train test split will first shuffle the entire data set so that data set for all 3 species will be available in training data as well as in test data. It will not be skewed. We get X train, X test, Y train and Y test from train test split method. X train and Y train will be used to train the model and X test and Y test will be used to test the trained model. Let's create the model with the help of the constructor. We know we will be using model.fit to train a specific model. In this case, it is Gaussian naive Bayes model. Once we have trained model, we can evaluate the score by passing test data as its input. In our specific case, Bayes model has accuracy of 1. That means each and every prediction will be accurate if we use this model. In other words, 100% of the time our Bayes model will predict the target column accurately. Let's understand the takeaway from this session. In this session, we have discussed about Naive Bayes algorithm, which is a supervised learning algorithm to solve classification problems. It works on top of Bayes theorem of probability. We have seen the mathematics behind it. Now we know there are 3 different types of Naive Bayes algorithm: Bernoulli, multinomial and Gaussian. These are the 3 algorithms we will apply based on a specific type of problem statements. We know how we can implement Naive Bayes algorithm in our machine learning code with the help of sklearn library. As Naive Bayes algorithm is fast and easy to implement, it is very popular among machine learning engineers and data scientists. There is a drawback of Naive Bayes algorithm because it assumes the features are independent, but in real life most of the features are dependent. We have written Python code to implement Gaussian Naive Bayes algorithm and we solved a specific classification problem with the help of the famous iris data. Hope you have enjoyed this quick session. Thanks a lot for watching this video.